Okay, so 978, and we're given this table here, and we're given that each of the legs are 2 pounds, and the top of the table is 15 pounds, and we're given the dimensions of the table. And we're trying to find two different things. We're trying to find uh, the height of the center of gravity, so how high up is the center of gravity from the base or the bottom of the table? And then secondly, the angle of the top surface, that how far can it be tilted without overturning, okay? So let's work on the first part, and in terms of the center of gravity, or the centroid, if you want to call it that. The center of gravity is a better term because we're talking weights here. Um, we have the sum of each of the composite shapes times the weight divided by the sum of the total weight here. All right, so let's do the top part of this equation first. So sum of z tilde a. And let's start out with the 4 legs. Okay. So we have 4 total legs, and we know that the centroid of each, or the center of gravity of each one of these legs here, is halfway up. So we know that all of those are halfway up the leg. And if the total leg length is 3 feet, we know that's 1.5, then half of 3. And then we have the weights of each is are 2 pounds. So each is 2 pounds. And then we also need to take into account the top of the table, and the top of the table is located from the base 3 feet away with a weight of 15 pounds. Okay, so there we have 57 pound feet. And then the sum of all the composite, or all the weights here, we have 2 plus 2 plus 2 plus 2, that's 8, plus 15, that's 23 total pounds. Okay, so all these added together. All right, so the center of gravity then is this value, 57, divided by 23, which we get 2.478 feet off the ground. Okay, so let's draw a quick little diagram of this table. And so we have okay, so the centroid here is right here, and we know the dimensions from here to here that's 2 feet, half the table width here, and then the distance from here to here is our value that we just found, 2.478, this direction. Okay, so now we're trying to figure out when it's gonna how far can we tilt the top surface without it overturning. And this is kind of the tricky thing to realize when this happens. And let's see if I can draw this. Okay, that's not the best drawing, but it's going to be supported by a normal force here. And it's when our center of gravity here, when it's directly in line here, it's at the verge of tipping over. And if we go any further than that, and let go, it's going to slam to the ground instead of tip back into its original position. So these are directly aligned here. And if we take a look at this triangle, we know that this leg is 2 and this leg is 2.478. Okay, and the angle that we're looking for is this, theta. And through our geometry here, we can figure out that this is also theta here. So this angle here is theta, which is exactly equal to this theta. So when these are directly aligned, this is the equation we get. So if we look at the tangent of theta, right, tangent is opposite over adjacent. So we have opposite, which is 2, and adjacent is 2.478. And by doing the inverse tangent there, we can figure out theta. So theta is the inverse tangent of 2 divided by 2.478. And we figure out theta is 38.9 degrees. And that is our answer for problems 978.